All right, so the first problem we're going to go over today is homework. This is homework 06. No, it's 05B. 05B. This is number 31 in the homework. Okay, and we
Okay.
want to find all the real solutions for the following equation. So really, this on the left side we have a polynomial. All right, and we call it a cubic because it's x cubed there. So this is bigger than the quadratics that we've been working with, because quadratics we only have x squareds. So the first thing we may want to try when solving, when factoring this, right? So we want to factor it to get the zeros, is we want to try, is it going to factor by grouping? So my advice is always try factor by grouping first. Always try factoring by grouping first. Okay, because if that method works, the problem goes extremely quickly. If that doesn't work, then it does not go quickly. So we can start by grouping the first two terms. Here, the first two terms have an x squared in common. And what we're left with is a 7x minus 3. And then in the second two, when we're factoring by grouping the second two terms, because the first term is negative, we're going to factor out a negative. So we're going to factor out a negative, and they both have a 5 in common. So we're factoring out a negative 5. And then what we're left over with is negative 35 divided by negative 5 is 7. So we've got 7x. And then 15 divided by negative 5 is negative 3. Okay. This is how you tell that factor by grouping works. When you have two of the same things in parentheses, factor by grouping worked. So we're actually going to factor those out once again. So we're going to have 7x minus 3. And what we're going to be left with then is the x squared minus 5. X squared minus 5. Okay. And all of this, I should have kept putting it all along, is equal to 0. All right. And then what we need to do now is you split it up. So either 7x minus 3 is equal to 0, or x squared minus 5 is equal to 0. To solve the one on the left, you can just add 3 on both sides. You get 7x equals 3, divide both sides by 7. X equals 7/3. That's one solution. Now, the second one, we have x squared minus 5. This is a quadratic. Typically, the way we solve quadratics is set them equal to 0 and then factor. This one does not factor, though. X squared minus 5 does not factor. So what we're going to do is add 5 on both sides to get the x squared by itself. We get x squared equals 5. And to get rid of the squared, we're going to take the square root on both sides. And when we take the square root, we want to add a plus or minus sign on both sides. So the square root and the square on the left side cancel each other. And then we're just left with x. And the right side, we get the plus or minus square root of 5. So here we have 3 answers. So when we're putting our answers, we're going to put 3 divided by 7, comma, the square root of 5, comma, the negative square root of 5. We have 3 answers. And we know in the beginning that we're going to have 3 answers, or 3 potential answers, because some of them might be duplicates. They might be the same one. But because of x cubed lets us know that we're going to have 3 possible solutions. All right, I'm going to pause it here. We're done with this problem, but we're going to take. All right, so what we're going to do here, well, first thing we want to do is read the directions here, right? So it says solve the inequality when f of x is less than 0, okay? And anytime we see this, f of x is less than 0, this means what this is asking is, for what values of x? For what values of x is the graph below the x-axis? Below the x-axis. Okay? Had this said, which it doesn't say, but had it, so because it doesn't say it, I'm going to do it in red, because ours doesn't say it. Had it said f of x is greater than 0, this would have been asking for the same thing, except when is it above the x-axis? Okay, so less than 0 means we're below the x-axis, and greater than 0 means we're above the x-axis. So in ours says when is f of x less than 0, which means we're looking when is the function below the x-axis. Okay, so to answer that question, right, we're following the graph. Right now we're above, we're above, we're above, we're above. Starting at -3, right? Starting at -3, our graph is below. Okay, so starting at -3, it's below. Now, at 0, it actually touches 0. So at 0, it touches 0, but is 0 less than 0? That is false. 0 is not less than 0. So what's that mean? We're going to use a parenthesis. So it's going to be from -3 to 3. Okay, but after 0, it starts going negative again, right? We're below the x-axis. So it's going to be union 0 to infinity, because as we just keep going to the right, it keeps getting further and further down, further below. So that's our answer right there. That's our answer right there to the question that number 3 asks. Okay, but we're actually going to do the same thing. So, okay, that's your answer right there. I'm going to pause it, see if there's questions, but we're going to continue this one and do the bottom part, even though it didn't ask for it. All right, so we're also going to find when f of x is greater than 0. So that's when is the function above the x-axis. So it actually starts above the x-axis. So as you go to the left, which is -infinity, it's above. When does it stop being above? Well, at that -3 area, it stops being above. And then actually for the rest of the graph, we are below, or at 0, 0, we actually reach 0. But once again, 0 is not greater than 0. That is not true. That's false. So this is the only interval on which f of x is greater than 0. All right, we'll pause the recording here. All right, so we can also solve polynomial or rational inequalities. We can solve them using a sign chart. Okay, so your first step to, right, our first step here, so steps to solving a polynomial. This one is a polynomial, but it also works for rational inequality. So it's polynomial or rational inequality. Our first step is going to be get 0 on one side. Get 0 on one side. Okay, I would always keep the highest power of x positive if possible. So here we have x to the 4th is greater than 121x squared. So the first thing we're going to do is subtract the 121x squared. The reason why we're subtracting 121x squared is so that we get 0 on one side of the inequality. So we're going to get x to the 4th minus 21x squared is greater than 0. Okay, and then the second step, we're going to factor this thing. We're going to factor it. Okay, so this does factor. This is a difference of squares. Well, actually, hold on, time out. It is a difference of squares, but we should always factor out a greatest common factor first. The first term has an x squared in it, and the second term has an x squared in it. So we're going to take out the x squared, and we're going to be left with x squared minus 121 is greater than 0. First step, always factor out that greatest common factor. And now we can talk about how x squared minus 121x is a perfect, it's a difference of squares. So the x squared stays the same, but the x squared minus 121, that turns into x minus 12, not 12, it's 11, it's just 11. X minus 11 times x plus 11, and that's going to be greater than 0. All right. I'm going to pause it here, though. See if there are questions up to this. All right, we're just going to finish this one up. The third step is find the zeros of the polynomial. And if it's a rational function, you also want to find the vertical asymptotes. But this one, it's just zeros. So how do we find zeros? Well, we just set it equal to 0. X squared, x minus 11 x plus 11 is equal to 0. And then split them up. Either x squared equals 0, x minus 11 equals 0, x plus 11 equals 0. And then, well, this just means x is 0, right? And then here, add 11 on both sides. X is 11, or subtract 11, x is negative 11. So we have 3 zeros. And the way you do a sign chart, and I know this problem specifically doesn't ask for a sign chart, but others do. And this is the way to solve rational and polynomial inequalities. So on the top, write a number line. So we're going to have negative infinity and then go to the smallest one, which is negative 11, then 0, then 11, and then infinity. And draw from those numbers, draw down a vertical line. Okay. What goes on the rows? The rows are on the left side of this are all the factors. So we've got x squared. We have x minus 11. And then we have x plus 11. Those are the factors of the function here. Oh, we're not going to do that. And then you draw an equal sign. So do it twice, right? It's equal to, and then the bottom is going to be the function. The function is all we actually care about. The rest of it is going to be just work to help us calculate. All right. So now all we got to do is pick a number inside this interval. This interval is the interval from negative infinity to negative 11. Well, let's pick like, I don't know, negative 15. Pick a number between negative 11 and 0. How about negative 5? Pick a number between 0 and 11. How about 5? And a number between 11 and infinity. How about 15? Okay. And what you do is everywhere you see x, write that number. So negative 15 squared is positive 225. You don't actually care about the number. You just want to know about the sign. That's why we call this a sign chart. We call it a sign chart because you only care about the sign, which means you can do these fairly quickly. In fact, x squared, no matter what x squared is always positive. So we don't even have to plug stuff in if we don't want to, although you can. Of course you can. All right. On the second row here, negative 15 minus 11. Well, it's negative 26, but we don't care that it's negative 26. We just care that it's negative. Okay. And negative 5 minus 11, that's negative 16. We don't care that it's negative 16. If you know that it's negative, just write that it's negative. 5 minus 11 is negative 6. Same story here, just care about its sign. 15 minus 11 is positive 4. Negative 15 plus 11 is negative 4, so that's negative. Negative 5 plus 11, ooh, that's positive 6. And then 5 plus 11 is positive, well, and 15 plus 11 is positive. Okay, the main thing we're interested in, though, is this very end. How do you get the end? By multiplying. If you multiply a positive by 2 negatives, you get a positive. So this bottom part, if you have an odd number of negative signs, it's going to be negative. If you have an even number of negatives, it's going to be positive. Okay, so for us, we have 2 negatives, a negative times a negative is positive. In the next one, we have 1 negative, so the function is negative. Here we have 1 negative, the function is negative. And the last one, they're all positive. If you multiply all positive numbers, you get a positive number at the end. Okay, so if the problem is asking for you to create a sign chart, okay, what you're going to put for the interval is going to be from negative infinity to negative 11. And then the sign that you're going to put is positive. Or you could say that means we're above the x-axis, right? For the next interval, it's going to be negative 11 to 0. And if we do that from negative 11, from negative infinity to 11, we were positive. From negative 11 to 0, we're negative. So that means we're below the x-axis. And then the next one's going to be from 0 to 11. That was also negative. Oop, that was also negative, which means we are below the x-axis. And the last interval is 11 to infinity. 11 to infinity is going to be positive, which means we're above the x-axis. Okay, so on those problems where it asks for sign chart, this is how you write your answers. Okay, and always make them, they're always open intervals. They're never closed. It's always open. So always use parentheses on sign charts. All right, so now we got to go back and answer the question. But what was the question? The question is, when is this greater than 0? When is that greater than 0? What type of numbers are greater than 0? Those are positive numbers. So in our sign chart, where was it positive? Well, we have them right here. Our answer is going to be this right here, this interval, and this interval. So the answer is going to be from negative infinity to negative 11, union 11 to infinity. Okay, that is going to be our answer. All right, let's pause here. So the problem that we just went through, I didn't write it down, but it's homework 05B number 12. It's number 12. Okay, so I'm pausing again. You can always go back and look. All right, so this one is homework 05B number 19. Okay, and we're going to go through it. The first thing it wants is a sign chart, right? It wants a sign chart. Sign chart. All right, so in order to do a sign chart, this is a rational inequality. We need to find the zeros. So the zeros, right? How do we find zeros? We set the numerator equal to 0. Okay, so that's our first step. To find the zeros, we set the numerator equal to 0. So we're going to have x squared times 5 plus x times x plus 6. When is that equal to 0? Well, that happens when x equals 0, or 5 plus x equals 0, or x plus 6 equals 0. So here we can just subtract, well, we don't want to subtract x. It's better to subtract 5 on both sides, sorry. Subtract 5. This one's done. You'll notice too, I will always circle my zeros because then I'll remember what they are. I will circle my zeros so I remember what they are. Subtract 5. So then we get x equals negative 5. That's a 0. I'm circling it. And then we're going to subtract 6, subtract 6. We get x equals negative 6 and circle it. Okay, those are our 3 zeros. I circle my zeros to remember that they were zeros. When you take x equals 0 and you plug it in the function, you get 0 as an answer. The vertical asymptotes, they're not even part of your domain. To find that, you set the denominator equal to 0. So for us, that's going to be x plus 7 times x minus 1 equals 0. So either x plus 7 equals 0 or x minus 1 equals 0. Subtract 7, x equals negative 7. Now, for the vertical asymptotes, I'm going to remember that, and I'm going to remember it by squaring it off, by boxing it. Add 1, x equals 1. Okay. All right, I'm actually going to pause here. All right, so when we're setting up our sign chart, what we are going to do is you always start at negative infinity, and then you got to go in order from least to greatest. So negative 7 is a vertical asymptote. I'm actually going to box it. Okay, in the number line, I'm boxing it to remember it's a vertical asymptote. Then we go to negative 6, I'm boxing it. No, I'm not boxing it. Don't box it. I circle it, right? It's a 0. Negative 5 is a 0. And then 0 is a 0. And then 1 is a vertical asymptote. And then infinity. Okay, this is a monster sign chart. It's a monster sign chart. That is A-OK. It's A-OK. We're going to take things one step at a time. All right. Now, you know what? We can just paste the function back here. So this is what our function was right here. Write all the factors. Now we're going to do the factors. So the first factor here is x squared. There it goes. The next one is 5 plus x. The next one is x plus 6. The next one is x plus 7. And the last one is x minus 1. After the last one, we do an equal sign. We do 2 bars for an equal sign, and then we have our function. Okay. Now you can just pick numbers in those intervals. A number between -infinity and -7, how about -10? A number between -7 and -6, how about -6.5? Number between -6 and -5, how about -5.5? A number between 5 and 0, how about -1? A number between 0 and 1, how about 1/2? Number between 1 and 10, how about, or 1 and infinity, how about 10? All right, I'm going to pause here. You on? So now what we're going to do is we're going to plug in -10 to each one of these and figure out their sign. So -10 squared. Oh, well, -10 squared is 100. And actually, if you square a number, it's always positive. So for all of the x squareds, it's going to be positive. We can save ourselves a little time. -10 plus 5 is -5. That's negative. -10 plus 6 is -4. -10 plus 7 is -3. -10 minus 1 is -11. Now, we can do this now. A negative times a negative times a negative times a negative. If you have 4 negatives, it's positive. If you have an even number of negatives, it is positive. All right, let's do the second one. -6.5 plus 5 is -1.5. It's negative. -6.5 plus 6, that's also negative. That's -1/2. -6.5 plus 7, the 7 is bigger and it's positive. So now we're positive. -6.5 minus 1 is -7.5. Now we have 3 negatives, which make a negative. If you have an odd number of negatives, it is negative. All right, let's go on to the next one. -5.5. -5.5 plus 5 is going to be negative now. Oh, it was negative before, but it's -1/2. But -5.5 plus 6 is +1/2. -5.5 plus 7, that's +1.5. -5.5 minus 1 is -6.5. And here we get a negative times a negative. 2 negatives make an, oh no, 2 negatives make a positive, right? 2 negatives make a positive. An even number of negatives make a positive. All right, what about, we can select either one of these. So let's select -4. -4 plus 5 is negative, right? Because we get, no, it's positive. I lied, it's positive because -4 plus 5 is +1. -4 plus 6 is +2. -4 plus 7 is +3. -4 minus 1 is -5. So 1 negative means it is negative. 1/2. If we do 1/2 plus 5, that's positive. 1/2 plus 6 is positive. 1/2 plus 7 is positive. 1/2 minus 1, that's -1/2. 1 negative means it's negative. And the last one, 10 plus 5, that's positive. 10 plus 6 is positive. 10 plus 7 is positive. -1, 10 minus 1 is 9, that's positive. The last one is positive. Now, you will notice something that happens on all of your sign charts. Once it starts being positive, it'll always be positive as long as you've factored this. Oh, no. Oh, sorry. There we go. Same thing here. Once it starts positive, it ends positive. So there's a lot of ways to make this go a whole lot faster. Okay. It's okay to do it slow though, too. You're going to have plenty of time on the test. All right. Or whatever. That's okay. All right. So what we're doing next now, what we're going to do next is actually fill this in. So I'm going to stop sharing this and I'm going to start sharing this. So what we want to put in for the interval. All right. The first interval, we have them, was -infinity. So negative, can we put I on F and it'll fix it? No. So negative, and then we have to select the correct thing. It's down here. There we go. -infinity, comma, -7. and it's always open intervals. And that was positive. That was positive. The next one is going to be from -7 to -6. And that was negative. And then the next one is -6 to -5. And I believe that one was positive. Then we went all the way from -5 to 0. And -5 to 0. And that was negative. And then we went from 0 to, I got to look, I don't remember. We went from 0 to, it was 0 to 1. We went from 0 to 1 and it stayed negative. 0 to 1 stayed negative. 0 to 1 and it stayed negative. And the last interval is going to be from 1 to infinity. So we got to use the infinity sign down there. And that was positive. All right, there it is. There we go. Let's check it, see how we did. Hey, we did fantastic. All right, so what's the solution? We can tell the solution from here, because what numbers are greater than or equal to 0? Oh, actually, you know what? I'm gonna switch it over. Because our hard work is gonna pay off. So we wanted to know where it was greater than or equal to 0. What type of numbers are greater than or equal to 0? They're positive numbers, but also because it can be equal to, it's positive numbers or 0. Zeros work. Vertical asymptotes never work. Vertical asymptotes never work. So when we're writing our answer, we want this positive. It goes from -infinity to -7. Infinity always gets a parenthesis. That -7 is a vertical asymptote. Vertical asymptotes never work. What's that mean? Vertical asymptotes always get parentheses. Vertical asymptotes always get parentheses. Okay. And then the next interval that it's positive is from -6 to -5. Now, these are zeros. So zeros get brackets if you have a greater than or equal to sign or a less than or equal to sign. So both of these are zeros. So both of these gets brackets. So we're going to put a union there. It's -infinity to -7, union -6 to -5, brackets on both. And then over here, one more time, we have union 1 to infinity. 1 gets a parenthesis because vertical asymptotes always get parentheses. How did I know it was a vertical asymptote? Because I boxed it. That's why it can be so important to box it to know whether you're using parentheses or brackets. So I'm going to stop this sharing. And then we're going to jump to, back to the question. And we're selecting the one that has brackets on -6 and -5 and parentheses. It's very, very, very tricky.
Excuse me, with that being said, you said the one that always gets bracket, what was it that you said the rule? It's greater than or less than equal to. Anytime you have a greater than equal to or less than equal to, there's always going to be a bracket.
Yes, that's for zeros. So if you got the number from the numerator, it's a 0. So let me stop sharing this and we'll go back. If you've circled it and it has greater than or equal to or less than or equal to. So actually I missed 0, right? Because 0 was a 0. So we should put union 0. 0 should also work.
So that, does that apply for everything or just this? Like any other problem, if I'm writing it in integral notation and I'm trying to determine whether it's a parenthesis or bracket, if the sign inside of the equation is greater than or less than equal to, greater than or equal to or less than or equal to, it's always going to have a bracket on that side of the number.
That is true.
Thank you. Okay.
However, I mean, if it's a vertical asymptote, it always gets a parenthesis though.
That's the exception.
Because vertical asymptotes, you can't plug them in.
Okay.
You can't plug them in. They don't have a value, which is why they always get parentheses. So if it comes from the top, right? If it comes from the numerator and it's greater than or equal to, it gets a bracket. If it comes from the top, it gets brackets. If it comes from the vertical asymptotes, it always gets parentheses.
And that's the bottom.
Correct.
Okay.
But if it just says greater than, you don't have to think at all. Everything's a parenthesis.
Okay.
If
What
it's
about
just
less
greater
than?
if it's just greater than or just less than, everything gets a parenthesis. You don't
All
even
right.
think about it.
Okay.
Yeah.
All right.
You're welcome, Tish. Great questions. All right, so let's go back to, what am I doing? We're gonna go stop share. We're gonna go to the next part of the question. So all right, I failed on that one. Okay, hold on. There's a way to share multiple things. I don't know it yet, but I'm gonna learn it. So this is the answer right here. We have brackets on the -6 and the -5, and we have parentheses on the -7 and the 1. So let's check it, make sure we're right. We did great. Oh, and that was it. So 19, Tish, let's pause here. That was it for 19. All right, this one says, give the vertex the axis of symmetry. Yeah, we're going to graph this one. This is good. And maybe it's not exactly what we were asked for, but that's okay. This one's a good one. So the vertex is, the way we find the vertex on these, if it's in a form where there's transformations, right? The vertex without any transformations, this is without transformations, is always 0, 0. All right, but we have transformations here. We have a -3 that belongs to the x, so we're going to add 3 to all of our x values. The x always does the opposite.
Which number are you on? I'm so sorry.
This is number 12. No, I'm sorry, I should have put it. This is homework 05A,
Oh, you're on
number
05A.
12. Yeah, I don't think was there any graphing in 05?
I don't know. I'm
I
not sure.
don't think there is, because we graphed rational functions before the midterm.
Right.
Yeah.
And I was just working on some of the stuff that I needed to get done, and I wanted to make sure that I was absolutely clear on how to do that moving forward, because it's something that I should absolutely know how to do.
And so, Tish, I will also say that you will not be asked specific questions on the final that were on the midterm.
Okay.
Obviously, there's some skills in math that build upon each other. So like, you have to be able to factor on the final and the midterm. But there's not going to be a specific question like, hey, what are the vertical asymptotes of this rational function? That won't happen. Or, do this mixture problem. That's not going to happen either.
And this is 5.
This is 5A.
Yes,
5A,
this is homework 05A number 12.
I don't know, man. I mean,
because every week you've got an A due and a B due.
because experience in it.
I'm gonna go ahead. We're gonna finish this one up. So the vertex is gonna be at 3, 4. Okay, so and actually we're gonna stop share and then we'll put that in right here so that we see what everything looks like.
Oh, my problem's different. I'm sorry. Mine's 2 squared instead of 3 squared.
Gotcha.
That's why I said mine's 2, 2. Okay.
Yeah,
Anyway.
okay, and everyone's going to be a little bit different. So that's going to be our vertex, and then we're going to have axis of symmetry is always, you always write it as x equals, and then it's whatever the first value of the vertex is. X equals and the first value of the vertex. All right, and the graph is concave. So this thing opens down. So if it opens down, it's concave. I hope it's concave down. Should be. All right. And so the graphing tool, this is where we can use the graphing tool. Okay. And let's see. Good. We can see the graphing tool. What we're going to use is this parabola button right here. And we know the point 3, 4. So here's 0, 0. We go to the point 3, 4. 1, 2, 3. 1, 2, 3, 4. That's our vertex. Okay. And now what we can do, if we plug in, well, we need one more point. We need one more point. So probably the easiest point to find is when x is 0, but maybe not. Maybe not. So if we plug in x is 0, in fact, let me stop sharing here and we're going to go back to the whiteboard. We'll just plug in x equals 0. Most of the time, it's not going to be so bad, but you could have problems where it's bad. So let's try g of 0. What happens when x is 0? We get -2 times 0 minus 3 squared plus 4. See, this might be too big. It's gonna be -2 times 3 squared plus 4. That's gonna be -2 times 9 plus 4. That's -18 plus 4, which is -14. So now we can go back and we can go to 0 and then 14. 0, 14 is a fine spot to put. Oh, except I messed up. So I'm going to redo it. I'm going to redo it. How did I do this before?
Clear it. Please hit clear.
Yeah, I did. I was doing it with the mouse instead of the touch
Oh.
screen. So I'm going to redo it. So clear it. Oh, thank you. That's what you're telling me. Yeah, perfect. So then we go to 3, 4. 3, 4 right here. And then we're going to go to 0 and then 14 right here. I would say that's probably the best. And then we're going to save it and make sure that it marks us right.
So your vertex plots are always your very first ones that you put, right? Yeah, because you put your 14 in there. That's why it's going to say it's correct.
Yeah, I messed up because it should have been -14, right?
Well, I think that you put a 0 in there. I think it was only 1 point, wasn't it?
Yeah, it was 0 and then -14. I put +14. That's my fault. So right here, it was 3, 4. 3,
Yeah, it moves
3,
down.
4. There we go. And it was 0, -14. I missed. All right, that's okay. We just got to stay patient. We'll get there. All right.
Welcome to my world.
3,
I'm
4,
telling
and
you,
then we'll
perhaps
go
got a pain in
there.
my- yeah.
And now we save it. And now we should be okay. Let's check it. All right, we're okay. So graphing, I would do the vertex and I would do the y-intercept. The vertex and y-intercept should work every time.
So when you do the parabola, when you click that parabola tool, your vertex points are always going to be your first point that you put.
Oh,
And
yes,
then
yes.
Your ending points, that's where I'm screwing up, I think, because I get where I put it right, but the ending part where it comes off of the graph,
Yeah.
that's where I guess I'm messing up.
I
So
got
your
you.
axis of symmetry, or what if you've just got your X and Y? So your X, okay, so that would be your X would be your first and then your Y would be your second point, right?
Yep. Well, no. Well, yeah, it's because that's where we got the 3, 4 from.
Yep.
And then so we have to find one more point. I would always find the y-intercept by plugging in x = 0.
Got it. Okay. All right. So that's, yeah, always, okay. Instead of just putting that 1 point and then I get it. Let's see where I'm messing
Yeah.
up.
Put the 1 point, the vertex, and then put the y-intercept, and you'll get it right every time.
All right. All right. I'll try that. That should help. Thank you so much.
All right. You're so welcome, Tish. So Tish, Andre, there's a survey in the chat if you want to fill that out. If not, that's perfectly fine. I'll be here again next week. So I'm always here on Saturdays. And since you guys are on Eastern time from 2 to 3.
Mhm.
Yeah, from 2 to 3. So yeah, if you have any questions, let me know. I'll put my email in the chat as well. If you have questions or anything like that, please let me know. You can always send me an email, and if you have more specific questions or anything like that. So
Okay.
if not, I hope you guys have a great rest of your Saturday, great weekend. Yeah, and I'll see some of you guys next week.
All right. Thanks. Have a good day.
Thanks,
Bye-bye.
man.
Bye-bye.